Now we discuss functions of one variable. And we will be discussing a quadratic function. So all of us are familiar with quadratic equations. Let us discuss quadratic function today. So any quadratic function will be of this form. Fx equals to ax square plus bx plus c, where a, b, c are real numbers or constants and a is not equals to 0. Because if a is equal to 0, I land up with a linear function. I am talking about a quadratic function, therefore a has to be not equals to 0. So this is the definition of a quadratic function. And generally, we replace fx by y so that it is very easy to see that we are actually working on the xy plane. So x is the independent variable, y will be the dependent variable. So x will be plotted on the horizontal axis and y will be plotted on the vertical axis. Now, so let's study some properties or some nature of quadratic functions. So let us try to convert this quadratic function into vertex form. Okay. Now, what do you mean by vertex form? When we draw the graph of a quadratic function, we either get an up opening parabola or we get a down opening parabola. Okay. So either we will get a U shape or an inverted U shape. Now, whenever we have an up opening parabola, there will be a point where the function will hit its minimum value. This is the vertex. And whenever I will have a down opening parabola, there will be a point where the function will hit its maximum value, and that is again the vertex. So this is the easiest form to know the vertex so that we should know how the parabola is going to be, up opening or down opening. Let us see how. Now, what is the vertex form of a parabola? If h comma k is the vertex of the quadratic function or the parabola, then I can write my quadratic function as a x minus h whole square plus k. I can convert this equation into this equation where h comma k is the vertex. Remember that we have a negative sign here and we have a plus k sign here. So if you put x equals to h, you can see for yourself. If you put h equals to x equals to h, we will get y equals to k. So h comma k is the vertex. Here is a negative sign. Here is a positive sign. So this is the vertex form of a parabola. And this constant a is the same as this constant a. So now we will learn how to convert a quadratic function which is given it in its raw form into a vertex form. Okay. So now, for example, let us start with the basic raw equation. Okay. Now we will be doing method of perfect square. So how do I convert this into, a perfect square? Because I'm looking for a form like this. Okay. Just keep this in mind. I want something like this. That means I want a into some perfect square. So what I do, I make the coefficient of x squared to be 1. So to make the coefficient of x squared to be 1, we take a common. So we will get x squared plus b by a, x plus c by a. This is the first step to convert something into vertex form or perfect square. Now, note the coefficient of x. The coefficient of x is b by a. Let's not care about the sign. Whatever is between, that will be taken care of. So the coefficient of x is b by a. So take half of the coefficient of x. So which is going to be b by 2. Okay, let's take its half. Then square it. Okay, so take the half of the coefficient of x, square it. Now what I'm going to do, I am going to add this square here And just to make sure that my expression is not disturbed, I am going to subtract the squares. This expression is unchanged. This is same as this because I'm adding and subtracting the same term from the expression. So now let us look very carefully. This is x square plus b by 2a whole square plus 2 times x times b by a, b by 2a x. Okay. Plus c by a minus b by 2a whole square. So this thing I have written like this. Okay. So that we get something like 2ab. So 2 times x and this x should be removed. So 2ab. So we have this formula in mind, square of a binomial, a square plus b square plus 2ab. So that has happened over here. A square plus b square plus 2ab. So now I have got my perfect square. That is square of a binomial. So y becomes a x plus b by 2a whole square plus c by a minus b square by 4a square. So now I can separate it because I am looking for this form. X plus b by 2a whole square plus a c by a minus b square by 4a square. So if I convert this into the standard form, this should look like y equals to a x minus b by 2a square plus a divided by a square. So we take a 4a square as LCM. So we'll have 4a c here and here we'll have b square. So this is the vertex form of a parabola. What I am interested in it is that the vertex occurs at x equals to minus b by 2a. At this particular point, the vertex is going to occur. Okay, from here we can know the h coordinate, and this entire thing is the value of k, which can be calculated easily. Now, my y is a x plus b by 2a whole square plus, okay, so we have this whole thing, so we have plus something. Okay, now let's discuss cases. Now what is going to happen? So this is the vertex form, so we know that the vertex occurs at x equals to minus b by 2a. And in fact, the moment I put x equals to minus b by 2a, my y takes the value something. So this is nothing but the value of f at minus b by 2a. Okay. So now, case 1. Now a is non-zero, that we already know. So if a is non-zero and we have a is a real number, it can either be positive or negative. Nothing else is going to happen. So case 1, if a is negative. Now, if a is negative, this thing, okay, so a x plus b by 2a whole square is less than or equal to 0 because a is negative and this thing is greater than or equal to 0 because it is a square. So that means this is negative. Okay. So y is equal to something less than or equal to 0 plus something. That means this constant a is giving some value which is going to decrease this thing. That means here y will be maximum at x equals to minus b by 2a. When x is equal to minus b by 2a, this thing is equal to 0 plus something. The moment x plus b by a whole square is negative, this thing is going to give a negative contribution. So something minus negative is less than something. So basically y will be a maximum. So If A is negative, okay, we are going to get something like this. So we will have a maximum at minus B by 2A. Okay, so we have a down opening parabola if A is negative. This is the first observation. The second observation we can again see here, case 2. Case 2 is A is positive. So if A is positive, A x plus b by 2a whole square is greater than or equal to 0. So y is equal to greater than or equal to 0 plus something. So that means at y x equals to minus b by 2a, we hit a minimum. Because when x equals to minus b by 2a, this is equal to something. And the moment x is not equals to minus b by 2a and a is positive, this will become positive. So something plus something positive is going to be greater than something. So therefore, it will hit its minimum. So in case a is positive, we will have an up opening parabola. Up opening parabola. So what are the observations? The observations are as follows. If y is equal to ax square plus bx plus c is a quadratic function, then vertex occurs at x equals to minus b by 2a. First. Second, it is up opening. It is up opening parabola if A is positive. Third, it is down opening parabola if A is negative. Now, let us have an example. Let's see. So, suppose we have something like this. Suppose we have something like this. So let's try to convert this into vertex form. You can directly come to know about the vertex because here A is 2, B is equal to 3, C equals to 1. So vertex occurs at x equals to minus 3 by 2a. So 2 times 2, which is minus 3 by 4. Okay. And if you look at the y value at this particular point, so you are going to get y equals to 2 minus 3 by 4 whole square plus 3 times minus 3 by 4 plus 1. So y will be equal to 2 times 9 by 16 minus 9 by 4 plus 1. So y will be equal to, let's take 8 as LCM. So 9 minus 18 plus 8. So minus 1 by 8. So we have the vertex minus 3 by 4 minus 1 by 8. So let us try to confirm it by converting it to the vertex form so that we understand what happened actually. So let's take 2 common. Okay. As told, take the half of 3 by 2, square it and subtract it. It should not be difficult. So if you're asked to convert a quadratic function into vertex form, you should know how to do it. Otherwise, by looking at A, B, and C, I can come to know what is vertex and what is the y coordinate at the vertex. Okay. So this will become 2x plus 3 by 4 square. This is being taught so that you know how to convert a quadratic function into vertex form. So this is, and then this is going to be half minus 9 by 16. So y turns out to be 2x plus 3 by 4 square plus 2 times half minus 9 by 16. So this is minus 1 by 16. So y turns out to be, so look at the beauty. We are able to convert. So this conversion is not required when it is not asked. You can find the vertex by looking at A, B, and C because we know that the vertex occurs at minus B by 2. minus b by 2a. And then you can know the y coordinate by just putting the x coordinate in this equation. But if you have to convert this into vertex form, this is how you do it. So from here, the vertex is minus 3 by 4 minus 1 by 8. Notice that a is positive. So a is equal to 2, which is positive. So we will have an up opening parabola. So now suppose I want to make a rough graph. How am I going to make it? So we have minus 3 by 4 minus 1 by 8. So this is the x-axis. This is the y-axis. So suppose we have minus 3 by 4 here and minus 1 by 8 somewhere over here. So this is going to be minus 3 by 4 minus 1 by 8. And just because we knew that it was an up opening parabola, we are going to go like this. Now this is a rough figure, okay? But remember one thing, just because the vertex is below the x-axis, this parabola will definitely cross the x-axis as 2 points. What it means is that the quadratic equation will have two roots, two positive roots, and let us confirm that. So what was our equation? So our equation was 2x square plus 3x plus 1. So what are the roots of a quadratic function? The roots of a quadratic function are those values where y is equal to 0. That means where the parabola or the graph crosses the x-axis. So 0 is equal to 2x square plus 3x plus 1. So how do you know that it has two different roots? So we calculate discriminant, which is b square minus 4ac. If discriminant is greater than 0, we have two different real roots. If d is equal to 0, we have two equal real roots. And if d is less than 0, we will have no real roots. So when I say no real roots, that means my parabola will not cross the x-axis. That means my parabola will be something like this. It will be above the x-axis, something like this, okay? So since my parabola in the given example is crossing the x-axis, let us confirm. So here A was 2, B was 3, C was 1. So D was B square minus 4AC, which is 3 square minus 4 times 2 times 1, which is 1, which is positive. So hence we had two different real roots and it is confirmed through the diagram. So if you want to make an almost accurate diagram of a parabola, you can calculate the vertex from the given parabola. You can either convert into vertex form or use the concept that the vertex occurs at x equals to minus b by 2a. Then you can find out the roots. So once you know the vertex and once you know two roots, you can easily draw a smooth parabola. Okay. Remember that the sign of a, that means the coefficient of x squared, decides whether the parabola will open up or the parabola will open down. Okay. So what are the tips? How to, how to draw a quadratic function. So how to draw a quadratic function? You will always have a quadratic function of this form, y equals to ax square plus bx plus c. Step 1, calculate roots. Step 2, find vertex. Step 3, check a positive or a negative to know the orientation. So for example, if you have something like this, like if you have something like this, ax square plus bx plus c, and suppose a is negative. So we mean that the orientation is going to be like this, okay? And suppose there are two real roots, distinct real roots, x1 and x2. So something like this is going to happen. This is x-axis, this is y-axis. Suppose one real root is this. Suppose another real root is this. Suppose here is my vertex v. Okay, and so my parabola will be something like this. So it is very easy to draw the diagram of a quadratic function because we know how to calculate the roots of a quadratic equation. Now we know how to calculate the vertex. So once we know the vertex and two roots, we are short clear that what is going to happen.